they are different lines. That means they are perpendicular. All right? Because only parallel lines have the same gradient. But if we have different gradient with this and that means they are perpendicular. So we use the same idea to say first gradient times the second gradient always give -1. We'll come back to this. I'm just trying to lay a foundation here. Okay, I want to set up a foundation here. Okay, so this is the cave. I'm going to show you now the question saying find the equation of the normal to the cave E. This is the cave, all right, with whose equation is this. So now this cave is okay, this equation of the normal is touching this cave at the point 2, -6 upper 2, -6. Are you getting this? Huh? All right, it's touching this point at 2, -6. So they want us to know this equation of this line. So how do we do that? We need to first know the gradient for this. We need to know the gradient for the cave. All right, if we know the gradient of the cave, we use this to know the gradient for this line. Then if we know the gradient for this line, we can easily find C. Then after we find C, we can now find the equation. All right, so now what we are going to do is we need to find the gradient. How do we find the gradient? We use the same given equation. So we are going to say y is equal to x squared minus 3x minus 4. So if we differentiate dy over dx, we get to find the gradient function. Okay, we get to find the gradient function. So if we differentiate this, here the x squared, its coefficient is 1. And the x, highest power is 1. So if 1 times 2, it is 2. X, this 2 reduces by 1, it becomes 1. Then -3 times 1 is -3. Then ex, it reduces by 1, so it becomes 0. Then every time you differentiate a constant, it always gives a 0. Every time you differentiate constant, these are numbers that doesn't have variables.